Okay, first thing that I want you to do is look at the POD. Since I am not in here to go over the POD with you, I'm just going to have you do it just following along. So you don't even have to write it down on the POD paper. Okay, so the first problem that we have is graphing, and this is our vertex form. So this is graphing our quadratic. Okay, so vertex form tells you the vertex. Okay, so we want to use the opposite of the inside, so the opposite of -3 is 3, and the outside stays the same, so +3, +2. So I'm going to plot my vertex. Okay, does anyone remember what goes directly through our vertex every single time? Our axis of symmetry, so x equals 3. So I'm going to draw my line of symmetry directly through my vertex. Remember, this is our line of reflection. Okay, so to get another point on my graph, we just want to pick a number close to our line of symmetry. So you can either pick 2 or 4. So I'm going to pick 2. So wherever I have an x, I'm plugging in 2. So I have 2 minus 3 squared plus 2. So we still want to follow our order of operations. So 2 minus 3 is -1 squared is 1 times -2 is -2 plus 2, which gives me 0. So I can draw the left side of my graph. And make sure that you're drawing a nice U, reflect it to the other side. So we know this opens down. A, which is 2, greater than 1, tells us this is narrow. Okay, so that was graphing in vertex form. So today we're going to be talking about graphing, except instead of quadratic functions, now we're talking about absolute value functions. So on the first slide of your pink notes, okay, I want you to graph y equals the absolute value of x using a table with your values from -2 to 2. So you're just making a nice t-chart with x values from -2 to 2. Okay, remember to get y, you have to plug in x. So I'm going to plug in -2. Remember, absolute value tells you the distance from 0. So the absolute value of -2, so the distance from 0 to -2 would be 2. Absolute value of -1 is 1, 0, 1, 2. So I'm going to plot these points. So -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Now looking at your graph, you notice that your points look like they're making a V. So since we're not doing quadratics anymore, think absolute value. So think value, you're graphing a V. So you're making a nice V for our graph. So looking at my y-axis, does anyone notice anything about the left side of your graph and the right side of your graph? Just like our quadratic functions, you're taking one side, flipping it over to the other side. So think of your axis as a line of symmetry. So it's still a reflection. So your vertex is the middle of your graph. Okay, so look at the next slide. Okay, this gives us our rules. And it's not that much different than vertex form for quadratic. So just like before, so get your highlighter. The sign out front, your plus minus, tells you if it opens up. So if it's positive, opens up. Negative opens down. A tells you wide, narrow, or neither. So this says normal, but we're used to using neither. So if A is equal to 1, we are neither. So we want to highlight that. Okay, if A is greater than 1, it's narrow. And if it is less than 1, it is wide. Okay, H, just like before, tells me my horizontal shift. So you're still think opposite. So you're still thinking opposite as before. So if H is positive, then you're shifting left. The opposite of positive is negative, which moves left. And if it's a negative, you're shifting right. K still tells me the vertical shift. If it's positive, it goes up. Negative, it shifts down. And to get my vertex, you're still taking the opposite of the inside, and the outside stays the same. So this is still the opposite. So we're going to use these to help us graph. So our first example, the first thing you want to get is your vertex. So we're still taking the opposite of the inside, so -1, and the outside stays the same. So -1, -2. If it helps you, draw your line of symmetry, but you do not have to draw that anymore. That's just if you need help to remember where to flip. Okay, so my left or right, so this is my horizontal shift. From 0, did we move left or right? We moved left. And again, from 0, did we move up or down? So my vertical shift, we move down. Okay, for my wide, narrow, or neither, we're still looking at just A. So 3. 3 is greater than 1, so we know we're narrow. Now, does this look like a V with just my vertex on here? No, so we have to get another point on our graph. So just like our POD, we evaluated a point, so that's what we're going to do here. So what is close to -1? We can pick 0. So wherever I have x, I'm plugging in 0. So I have a -3, my absolute value of 0 plus 1 minus 2. 0 plus 1 is 1. The absolute value of 1 is 1, so I have -3 times 1 minus 2, which gives me -5. So I plugged in 0, and I got -5. So I can draw that side of my graph, making sure it's a nice straight line, and I'm going to reflect it to the other side, making sure that is a nice straight line. Make sure you put the arrows on the end, showing it's continuous. So you can either evaluate a point, or just let's make an observation here. So look at your vertex. To get to the point I evaluated, I went down 1, 2, 3. So I went down 3, and then I went right 1. So I went down 3, right 1, which gives me -3. And look, the term out front, the number that you have out front is your slope. So you can either evaluate a point, or from your vertex, just use this number as a slope. So you went down 3, right 1, draw your line, and reflect it to the other side. So there's a little trick, a little faster way that you can graph. So we're going to use that for the next example. So just like before, we're going to find our vertex first. So the opposite of the inside, outside stays the same. So I'm at -1, 5. Okay. So for my horizontal shift, we went left from 0 and up. So that was my vertical. A is 1/2. 1/2 is less than 1, which is wide. And to get the other point on my graph, remember, you can evaluate or just use your value in front. So 1/2. So you have a slope of 1/2. So you're going up 1, right 2. So you went up 1, right 2. And I'm going to draw a nice V. So up 1, right 2. Actually, I'm going to make that with my other line. So you're still going up 1, right 2, and then up 1, left 2. Now, say you did want to evaluate a point. Say I wanted to pick 0. If I plugged in 0, you have 1/2 times the absolute value of 0 plus 1 plus 5. So 0 plus 1 is 1. So 1/2, the absolute value of 1 is 1. So 1/2 plus 5 gives me 5 and 1/2. So at 0, if we would have went up to 5.5, that's still on my line. So you can either work it out or just use the number in front as your slope. I want you to try this next one. So I'm going to give you a couple seconds to do this one at your seat. Okay, so my vertex, remember you want to use the opposite. So 4, outside stays the same. Draw your line of symmetry. Again, you don't have to draw the line of symmetry. Some of you, it may help. So my horizontal shift, I went right. And vertical shift, I went down. Okay, what's in front of my absolute value here? There's nothing here. Think of that as a positive 1. So I know that is neither. 1 is equal to 1, so I know it's neither. And now you can either evaluate a point, so you could pick 3 or 5, or use this number in front, a positive 1. So from my vertex, I'm going up 1, right 1, up 1, left 1. And then you can make a nice V. Okay, and the last one for the graphing, Again, use your opposite of the inside. Outside is the same, so I'm at 3, 2. Again, if it helps, draw that line of symmetry. Okay, from 0, did you go left or right? Right. And did you go up or down? You went up. So this is my vertical, this is my horizontal. Okay, and then we're looking at the 2. 2 is greater than 1, so we know that's narrow. And then you can either evaluate a point, so you could pick 2 or 4, or you can use that -2. You know your slope is -2. So you're going down 2, and you remember it's always over 1. So down 2, right 1, which means you can go down 2, left 1. Okay, say we wanted to double check. So say I plugged in 2. So I have 2 minus 3, which is -1. So I have -2 times the absolute value of -1 plus 2. What's the absolute value of -1? 1. So -2 times 1 is -2. Plus 2 is 0. So I plugged in 2 and got 0, which is in fact a point on my graph. So you can do either way. This is just the way you can double check also. Okay, now we're done with the notes, but flip to the back side of your paper. These aren't on there, but this is on your homework, so I want to make sure that we go over it. Okay, so we want to write an equation representing our function. So before, they would give us the function and we would graph it. So if you look back, the first thing we did every time was find the vertex. So we're still going to do that. Look at your graph, and we're going to name our vertex. So we're at -2, -3. So we're going to use that to fill in our equation. So think back, the last problem. When I got my vertex, I used the opposite of the inside. So if I know the x of my vertex is -2, I know this has to be a +2, and the outside stays the same. That never changes. So you take the opposite of the inside, outside stays the same. So that is correct. And then to get your value of a, remember the shortcut of finding the slope? That's how we're going to get our value of a. So from our vertex, we're going up 1, 2, 3, 4. So up 4 is a +4. And then I went right 1, which is a +1. So I went up 4 over 1, which gives me a +4. So I know y equals 4 times the absolute value of x plus 2 minus 3. Okay, so I want you to look at the next one. I want you to try figuring this one out. So again, find your vertex first. So I'm at 1, 2, 3, up 3. So again, set up your absolute value. Okay, we know the first number, our x, is always the opposite. So an opposite of +3 is -3. Outside stays the same. And to find my value of a, this is my slope. So from your vertex, to get to a point, you went down 1, so -1, right 3, so +3. So I went down 1, right 3. Okay, your homework is 2.7 practice. The first 6 problems you are not graphing. All you're doing is answering the questions on the back side, the first 4. So the first 6, no graph, just answer the questions. 7 through 10, make sure you graph and at least write the vertex. If you want to write other things, you can. And 11 and 12, you're writing the equation. So again, first thing you want to do, first find vertex. Okay, if you need to, watch the video over again to help you with some of those examples. If you have questions, I can answer them tomorrow.